Okay, so let's look at this problem. So this is number 25, and that's on page 424. And you have x squared minus 4x equal 32. All right, so what kind of equation is this? Quadratic. So how are you going to solve this quadratic equation? Put in standard form. Okay. So that means I've got to bring that 32 to the other side.
Yeah, so I'm just asking him the same thing. It seems like it's out of focus. Yeah, I need glasses and worse than normal tonight.
So x squared minus 4x.
Minus 32.
All right.
Equals 0.
Then remember, you always look for a GCF first.
GCF.
So GCF is 1.
Oh, yeah, that's right. Never mind.
So remember, in your test Tuesday, you have factoring on there, so make sure you know how to factor. Okay, so what are going to be the two factors?
X.
I'm going to try 8 and 4. And the 8 would have to be negative. The 4 has to be positive. And always check yourself. The outer is 4x. The inner is negative 8x. And when you add them up, you get negative 4x, which is what you wanted. Okay, now what's the property you're going to use next? What's that property called? Okay, so that means you said each one equal to 0. So x minus 8 equals 0. X plus 4 equals 0. So the zero factor property says that if you have two or more factors as project to 0, then definitely one of them has to be 0. So it's that each one equals 0. So notice I went from a quadratic equation to two linear equations. So what's x over here?
Positive 8.
What's x over here?
Negative 4.
So those are your two solutions. So your two solutions are 8 and negative 4.
Gosh,
These kind of aren't on the test this time, huh?
yeah, they are.
They are
What now?
quadratic equations.
No, that's not on test.
I
I
thought they were on that.
don't think it's on the study guide. Look at the study guide. Okay, so 73, you have 3x squared plus 8x minus 11 equals 13 minus 6x. So what do you do?
Oh. Okay.
Come on, guys. You got to be quick with this.
Would you if you're moving it to the other side?
Put in standard form. If you're going to use a zero factor property, what number must be on one of the sides?
0.
0.
So
you've got to subtract 13 from both sides and then add 6x to both sides.
Okay.
You've got to, that's 8x.
All right,
So
you would have
3x squared
plus
8x
minus 24 is equal to negative 6x.
Oh, what's the next step?
Add 6x. You would add that to the 8x. You would get 3x squared plus 14x minus 24 is equal to 0.
All right.
Sir.
Okay, now what's the next step?
Well, you would look for a GCF, and the GCF would be 1 because you got that 3 there, and that just doesn't work. So you would break it down.
All right, so what are the possibilities of 3x squared? There's only one.
X and 3x.
3x and x. All right, 24. What do you want to try?
Is that 14 in the middle?
That's 14.
There's 6 and 4. There's 8 and 3. There's 2 and 12.
2 and 12.
2 and 12?
Both positive.
Okay. So if you want to do 2 and 12, can I put the 12 here?
No.
No, because then that means you could take out a 3, which meant that these were, the GCF here is a 3, and it's not. So you have to put the 12 here and the 2 here.
And they're both positive.
No, they're not.
So you
No,
gotta-
'cause that-
you gotta
Last
go
sign's
what,
negative.
positive 14?
Last sign's negative.
Oh.
So the last sign's negative means one's positive, one's negative. So this is 36x, this is 2x. When you subtract them, does that give you 14?
Negative.
So that's not going to work.
Oh, I was thinking you had.
My bad, peeps.
6 and 4. So you would have to put the 4 here and the 6 here.
There.
So the outer is 18x, the inner is 4x. When you subtract them, you do get 14x. But you want a
Negative one.
positive 14,
And
so you want a positive 18 and a
Negative.
negative 14. So that means the 6 has to be
positive.
negative.
Or, no, sorry.
Got to be careful in that test. And the 4 has to be positive. All right, so you need, some of you need to be careful in that test. It's coming up with the factoring.
All right.
All right, and so this is 3x plus 4, x minus 6 equals 0. So what's the next step?
Zero factoring.
So I said each one equal to 0. All right, so I went from a quadratic to 2 linear. So 3x equals a
Let's go.
negative 4.
4.
So that means x is equal to what? Negative 4 thirds. Over here, what's x?
6.
6.
Alrighty then.
All right, 71. Jeez, dude.
Yours is worse than mine.
Hey. 7x cubed minus 7x equals 0.
GCF.
All right, what's the GCF?
7x.
7x.
Now notice this is not a quadratic, but it is cubic. But you're gonna solve it the same way.
7x.
So 7x times
X
x squared minus
minus
1
1.
is
All right.
equal to 0.
Okay, now what?
I guess you then factor for 0? Or would
No, you have to,
You can factor this further, guys. What's x squared minus 1?
X
Is the
minus-
difference of two
x
squares.
plus
X
1
plus 1, X
times
minus
x
1.
minus 1.
So on the test, you need to make, you see, on the test, I could have just said factor 7x cubed minus 7x. That's what you can see on the test, factor this. So you have to know you have to take out a 7x and you're left with x squared minus 1. At this point, you all need to know that this is the difference of two squares. And so when you factor the difference of two squares, you get x minus 1 times x plus 1. So know where you're at right now, guys, for this test.
Yeah, we're screwed.
Okay. Now what are you going to do with this right here? Zero factor property. It said each factor equal to 0. So you can think of this 7x as one factor. And you have this x minus 1 and this x plus 1. So you have 7x equals 0. You have x minus 1 equals 0. And you have x plus 1 equals 0.
All right,
X,
so
X equals 0 on the first one.
x equals 0, x equals 1, x equals negative 1.
All right. But notice where many of you were having a difficulty with difference of two squares.
I was getting there, I just didn't remember the terminology for it.
You got all the terminology. All right, now. Okay, suppose you had. So when we first started this, we looked at this example. X plus 4 times x minus 3 equals 0. So we looked at something like this right when we started the zero factor property. So given this equation, and this is quadratic, how do you know that this is a quadratic equation?
Because it, 1, 2, 3, it's got the,
You got two x's, so
Well, if you FOILed it out, what's x times x?
X
X
squared.
squared. So it's quadratic.
so yeah, that'd be the difference. between
Okay.
squared.
Now, what would you do next? How would you solve this?
zero factor,
Zero factor problem. It's already factored, right?
right?
So you said each one equal to 0.
X plus 4 equals 0, x minus 3 equals 0.
And then you would get x is equal to negative
Negative
4,
four.
x is equal to 3.
All right. Now, what if you had this?
Oh.
Okay.
Subtract, well, no.
Can I set both of those equal to 8? Just like it did both of those equal to
No, you
0?
gotta turn the 0 on one side, so you'd have to subtract 8 from both sides, huh?
Yeah, at some point you have to subtract 8. So the point is that there are some students that don't think very carefully with this, and they overgeneralize. So they'll say, well, I'm going to use the zero factor property here, without really knowing that in order to use it, what number must be here?
0.
0. So they'll say x plus 4 equal 8. Now this is wrong.
Thanks for clarifying that.
And then x minus 3 equal 8, and then they'll say x equal 4 and x equal 11, right? Okay, but first of all, if you look at the 11, if you check it, what's 11 plus 4?
15.
And what's 11 minus 3?
8.
Is 8 times 15 equal to 8? No, so
8 times
so
15.
so x equal 11 is not a solution to this equation. Now, 4 works. What's 4 plus 4?
8,
4 minus 3.
1,
8 times 1 is
8.
8. So the problem when you're not using the zero factor property is you're getting one of your solutions wrong, the other solution correct. So it's not telling you what your solutions are. All right, so you have to have 0 on the other side. All right, so the best way to do this problem, so this is new. So when we do this one, I'll give you those, you can now do those worksheets, I think. All right, what you want to do first is FOIL the left side. So when I FOIL the left side,
X squared,
I get x squared. What's the outer?
3x,
Negative
Negative
3x. Inner
Plus
plus
4x.
4x,
and last
negative,
equal 8, right?
Mm-hmm.
Combine like terms, I get x squared
Minus x.
plus x.
Plus x, sorry.
You'll got to be careful on that test.
Okay,
and
so
now you gotta subtract 8 from both
Now
sides.
subtract 8 from both sides.
Okay, so now
So 0 and allows.
x squared plus x minus 20 is equal to 0.
Okay, now how do you solve this quadratic equation?
0 factor. No.
The difference
Oh,
of
geez. No, there's one. Well,
Two binomials.
okay.
XX. I think 5, 4, right?
mhm,
5 has to be positive.
4.
4 has to be negative. And you gotta always check it. The outer is negative 4x. The inner is 5x. When I add them up, I get x, which is what I wanted. Okay, now what's the next step?
Zero factor method.
So x plus 5 equals 0. So what's x here?
Negative 5.
Over here, x minus 4 equals 0. What's x?
4.
So those are your two solutions, negative 5 and 4.
Okay.
And you can check negative 5. We know 4 works. Now, if you check negative 5, what's negative 5 plus 4?
Negative 1.
What's negative 5 and a negative 3?
Negative 8.
Negative 1 times a negative 8 is a positive 8.
So if we get something that isn't 0, FOIL it out and then subtract said number from both sides, and we'll be able to continue as normal.
Yeah, now, if you look at 32, right. But you said FOIL. So if you have this one, this is 32. You wouldn't FOIL the left side.
Distributive
You
property.
use a distributive property. So you get
4x
4x
squared.
minus, oh, I can't read it.
11x equal 3.
Okay.
Okay, now what?
The
Subtract 3 from both sides.
subtract 3 from both sides.
All right.
Now you have the two polynomials, 4x and x.
There's only one possibility for 3.
1 and 3.
Or you want to put the 3? First parentheses, second.
The second, because it's got to be negative.
All right, so the last sign's negative, so these signs have to be different. So let's check this. So the outer is 12x, the inner is 4x. When I subtract them, do I get
11.
11x?
No, you get.
I'm sorry, I said 4x, I meant what? X, right? That's 1x. So do I get 11x?
Yes.
Yeah.
It is a negative 11x.
Okay, but I need the 11 to be
Negative.
negative, so that means that 12 would have to be,
Negative.
and this would have to be,
Positive.
well, if the 12x negative, that means 3 has to be
Negative.
negative, and the,
Positive.
all right. Okay, what's the next step?
0 factor.
So 4x plus 1 equals 0, x minus 3 equals 0. Here, 4x equals a
What do you think?
negative 1. So what's x? Divide both sides by 4, negative 1/4. Here, what's x?
3.
3. So there's your two solutions, negative 1/4 and 3. All right, and then finally, let's look at 64. All right, 64. So 64, you have y minus 5 times y minus 2 equal 28. All right, so if you can't set each one equal to 28. You know that's not going to work. You got to follow that out. So when I follow that out, I get y squared. What's the outer? Inner.
Negative 5y.
Last
Negative 2y.
equal 28.
Okay.
Combine like terms. Y squared.
Minus 7y plus 10 is equal to 28. Subtract 28 from both sides, then you would get y squared minus 7y minus 18 is equal to 0.
All right, so y squared minus 7y minus 18 equals 0.
Two binomials, y and
On
y,
both sides.
and then you got a 7y.
9 and 2. 9 would have to be negative. 2 would have to be
Positive.
positive. Okay, next step.
0 factor.
To set each one equal to 0. So y has to be
9,
9. Y has to be
negative.
negative 2. Okay? All right, so that's what we talked about last class period. And I think I gave you the worksheets on those.
We have 6.6 part A and B.
Okay. So 6.8 and B. And I think you can do all of them. I think there may be one like this. Is there one like this? So that would do a week from Thursday. So it's not due on test day, it's due the following Thursday. But you need to start working on that though, because don't wait until after test day to work on this. You only have 1 day or 2 days.
2 days.
All right, so any questions on this? Remember, in order to do this, you gotta know how to factor.
Yeah.
In order
We
to,
gotta work on that.
hopefully you know how to factor right now because it's on your test, it's coming up. All right, so you can start taking the test around 6:30 or so if you want to. But remember, if you get here late,
That's less time.
you only have till 8:45, and that's it. So it's to your advantage to get here before 7:30.
I had a class, so I don't have.
I'm just letting you know, you have until 8:45. Okay. Yeah, till the time the class ends.
Next tab, wait.
Okay? All right, now, okay, so again, with what we're about to do, you still need to know how to factor. So factoring, you're gonna use for most of what we're going to end up doing. Okay, so it's not a difficult section as long as you know how to factor. So this is section 7.1. It's not a difficult section. So this is where we start talking about rational functions. So that's one part of it.
Rational functions don't sound very rational.
And the other part of this is where we're going to simplify rational expressions.
Are they simple?
Okay, so rational functions will be the first part that we're going to look at, and then rational expressions, we're going to simplify those. That'll be the second part of this. So your first test, you had functions in the first test, and you have functions in the second test. Make sure you go back over that first test, some of you, especially with the part on functions. So remember the function notation? So let's just kind of review this for a moment. So if f of x equals negative 2x squared minus 3x plus 1, so we have this function. Now this particular one is called a polynomial function. Our polynomial function. So basically, a polynomial function, your exponents are whole numbers. They're whole numbers. So remember, whole numbers are 0. What's the next whole number? 1. Next one, 2, 3, and so on. Right? Those are your whole numbers. So I didn't say anything about negatives. Whole numbers are not negative. Whole numbers are 0. 1, 2, 3, 4, and so on. So notice this exponent is 2, this exponent is 1, and there's no exponent there. Well, technically there is, but it's 0. It's 0. So polynomial function looks like this. So this is a polynomial. All right, so right now just kind of have an idea what it looks like. So on the previous test, you were asked to find f of negative 2. So how'd you find f of negative 2?
Plug in the negative 2 really next.
All right, so you'd say negative 2 times negative 2 squared minus 3 times negative 2 plus 1. And then use the order of operations. So negative 2 squared is
Positive 4.
4. 4 times negative 2 is,
Negative 8.
so this part's negative 8. This part is
Negative 6.
positive
Or
6 plus 1. Negative 8 plus 6 is,
Negative 2.
negative 2 plus 1 is
Oh, plus.
Negative 1.
negative 1. So f of negative 2 equals a
Negative 1.
negative 1. All right, so that's a polynomial function. That's what a polynomial function looks like. In fact, this is quadratic. X squared, that's quadratic. It's a quadratic function. A rational function has this form. So remember the function notation, f of x, g of x, h of x, k of x, whatever it may be, but it's a polynomial divided by a polynomial. So a rational function is a ratio of two polynomials. So it's a polynomial divided by a polynomial. So here's some examples. F of x equal x plus 1 divided by x plus 2. That's a polynomial function. Notice the numerator, x plus 1 is a polynomial. The denominator, x plus 2, is a polynomial. The ratio is called a rational function. Here's another example. G of t equal t squared minus 3t divided by t. There's another example. A polynomial divided by a polynomial. The numerator is quadratic. The denominator is linear. T to the first power is linear. T squared minus 3t is quadratic. These are both what? What kind of polynomials are these?
Linear.
Linear. H of x equal x squared minus 3x minus 4 divided by 3. That's a polynomial. I'm sorry, that's a rational function. The numerator is quadratic. The denominator is a monomial. It's linear. Remember y equaled 3? When you graph y equaled 3, what's y equaled 3? Isn't that a horizontal line? So that's linear. Now I made the last two quadratic, but it could be x cubed, it could be x to the 5th, whatever it could be. All right, but this is what a rational function looks like. All right, now one of the things you're going to be asked to do about rational function is this. All right, so you're going to be finding the domain of a rational function. All right, so let's talk about finding the domain. So remember when you on that first test you talked about domain and range. Domain is a set of x coordinates. The range is a set of y coordinates. So when finding the domain, you're looking for what values of x can I substitute into this expression, into this function. So when we go back to, let's say, this one, let's say you had 3 divided by x minus 2. So what you may want to do first before finding the domain is ask yourself, what number can I not use for x? What do you think?
0.
Mm-mm. No, I can use some negative numbers.
2.
2. I cannot use 2 for x.
Oh, less.
Because 3 divided by 0.
Because you have, in the denominator, you have 0. And you cannot divide by 0. So 3 divided by 0 is undefined. So when finding the domain of a rational function, you may want to look for the restrictions first. To find the domain of a rational function,
Look for restrictions.
find the restrictions. And so basically, your rational function has a denominator, correct?
Mhm.
And your denominator cannot be 0 because you can't divide by 0. So to find the restrictions, you're going to set the denominator equal to 0. You're going to set the denominator equal to 0 and solve that equation. So the one I just gave you is an easy one. You could have done that in your head. But basically, if you follow that step, you would set the denominator. What's my denominator here? What's my denominator?
No.
What is the denominator? X minus 2. This says I do what to it? Set it equal to
0.
0. And then I solve this equation. So x equal 2. So what I found is that I can use any number for x except what?
2.
2. So then your domain is this.
Basically everything but
All right. So on my math lab, they're going to ask you to write this in set notation. So here's how you're going to write this. You're going to say the set of x's such that, and then they'll say such that x is a real number. So that x is a real number, and x cannot equal what?
2. Positive 2.
And you have to write it like this: x cannot equal 2.
that after the first X, that's just like a
That's such that.
slash.
Yeah, it's like a vertical segment meaning
Oh,
such
it's a
that.
vertical line? Okay.
So the set of x is such that, this means such that, x, and you got to say x is a real number, and so basically x is any number, but x cannot equal what?
Positive 2.
Positive 2, because 2 makes my denominator
0.
0. So as you do this, to find the domain of a rational function, you're going to take the denominator and find out where is it 0. And then your domain will be every number except those numbers. All right, so
Paragraph, right.
number 2, and this is going to be on page 452. Number 2, you have this function. G of x equal 4 minus 3x divided by 2. So,
Your variable's on the top this time.
right, so it doesn't matter what's in the numerator. All you're looking for is what's in the denominator. Okay, so what is the denominator?
2.
2. But there is no variable, right? So when you kind of set the denominator equal to 0, it doesn't make any sense, because is 2 equal to 0?
No.
No.
It can't ever be.
So are there any restrictions?
No.
There are no restrictions. So that means that your domain is any real number. Y'all understand there's no restrictions, right?
Real number.
Because there's no variable in the denominator. There are no variables in the denominator, so I can use any number for x.
Okay, so we would just put the
So keep in mind that there are no restrictions
If the variable was in the.
since there is